Alright guys, welcome to Math 0106. This is lesson 4. Today we're going to start off with understanding fractions and what a fraction means. And here they have a diagram to illustrate what a fraction really is. So what you'll see is that the bottom number, which is called the denominator, indicates how we cut up the circle. So we've cut up the circle into 8 pieces. The numerator, the number on top, indicates how many are the shaded region. So when we look at this, for example, in number 1, we can see that we've cut the figure into 2 pieces, and we've shaded 1. So that would be a representation of 1/2, and so on and so forth. So you can see here they've done this example. They've shaded in 1 entire circle. So there's 1, and then there's a half, so it's 1 1/2. So each of these is, I feel, is pretty straightforward. So we can see here that this is going to become 1/3. We shaded in 1 piece, and we have 3 total. This is going to be 1 2/3. This is going to be, because we have 2 shaded circles entirely, so this is 2, and then we have 1 of the 3, 2 1/3. Then we have 3 2/3. Over here we have, and I know that this goes 1, 2, 3, 4, 5, 6, and this is 12, 13, 14, 15, but I'm just going to go ahead and do this side here. This is 2 3/4. Let's see here, we have 1, 2, 3, 4, 5, 6, and I actually recommend, as these circles get cut up into smaller pieces, to label the counting. One thing that I find that students do is it's very easy to make a silly mistake in counting. This is going to be 6, 14, it's the same image as above, so that's going to be 1, and then we have everything shaded but 1, so that would obviously be 1 5, 6. 15 is going to be 2. And this is actually going to be, these are 8s, because you can see you have 1, 2, 3, 4, and then you repeat on the other side. So this is a total of 8. So this is 2 out of 8. Here we have 1, 2, 3. So it's 2 3/8. 16, we have 1, 2, 3, 4, 5, 6, 7, 8. I would be labeling it, my pen is too thick, so it'll be hard to see, the numbers will get bunched up. So it's 1, and over here we have 1 out of the 8. Was that 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. 17's interesting. It's just 1, because it's just 1 circle. And so over here, we got through 17. So let me actually do this. So what I want you to do here is, I have left the last bit here. Go ahead, if you haven't done so already, and try to do this on your own. So pause the video now and try these on your own. I'm going to assume that you've done so, and let's finish this up together. So here again we say that we've cut it up into 4s, so it's 1 out of 4. Here we can see we have 1 1/4. Here we can see we have 2 1/4. Here we can see we have 2 and now 3/4. And what we can see in number 11, they work this one out, and they say we have 2 2/4. And what they want you to realize is that we can convert this into this version here. This is called an improper fraction. And what an improper fraction is a fraction where the numerator is greater than the denominator. So the number on top is bigger than the number on the bottom. So something like 5/2, 5/3, these would be examples of improper fractions. Something like 1/3 is a proper fraction because the denominator is greater than the numerator. Okay? So how do we take 2 2/4 and convert it into an improper fraction? Well, what you do is you multiply these together, and then you add the top. So 2 and 2/4 would be 4 times 2 is 8, plus 2 is 10, and it would be 10/4. Sometimes this is called the Texas method, because you're adding on the top and you're multiplying on the bottom. It's the abbreviation of Texas. And I kind of want to go in a little more depth about why this is the case. And that's because 2 and 2/4 is 2 plus 2/4. But 2 is 1 plus 1 plus 2/4. And what we need to realize is that 1 is just 4 out of 4, right? And 1 is just 4 out of 4. And the last one is 2/4. I mean, we can literally visualize that here, right? We see we have 1 here, and you have another 1 here, and then you have the 2 out of the 4. And so the reason why I'm pulling this up is, and this is a little bit, we're going to talk more about this a little later, but when the denominators are the same, we can add the numerators. So 4 plus 4 is 8, plus 2 is 10. So it's 10 out of 4, which is what we've been doing, actually, right? And that's why it works. There's something else to note here, and again, we will talk more about this later on in the course, but let me use a real life example. Let's say that I frequent a pizzeria, and because I go there so often, when I get a slice of pizza, they actually give me half the pizza. All right, and then we decide to go celebrate you finishing the course, and so we all go and we get some pizza, and I buy my regular slice, I'm using air quotes here, and then you buy a slice of pizza. Let's say this is a New York pizzeria place, so they give you almost like a quarter of the pizza. And you have to pay for this piece. Now, if we're paying the same price, you would be upset, presumably, right? Because you're getting a lot less pizza than me. And I could argue, well, look, I'm getting one slice and you're getting one slice. What's the problem? Right? And the problem is that mine is divided in halves, whereas yours is divided into fourths, right? So the question would be, how do we get around this problem? Well, the answer to that question is to take my pizza, and if I cut my pizza into the same slices as yours pizza, if I get the same denominator, then we can see 1/2 is really the same thing as 2/4. So now when we look at this, we can compare them equally, right? And so this is why fractions are important. This is why you can't just add fractions across and say this is like 2/4 or 2/2 or something like 2/6 or 2/8 or something like that, right? You have to get them to match, the bottoms to match up in order to compare. So this is why getting if you recall from grade school, getting a common denominator is so important. Okay, but we'll talk more about that in depth as we progress through the course. Let's go back to 17, and for the rest of these, let's go through, and if you get an improper, let's convert it into a mixed number. Okay, so 17 is just 1. I think we did that one on the other page. 18 is also just 1. Again, we could also say these are like 2/2 and 3/3 if we wanted to convert them into improper. I guess they wouldn't necessarily be called improper, but we could convert them into a fraction that way. And then number 19 is going to be 2 1/4. Notice that we have, and you can see this most clearly in the last one, you shaded 1 out of the 4. And if I convert this to an improper, we're going to go 4 times 2 is 8, plus 1 is 9. So we get 9/4. This is just 3. The one thing about 3, the reason why I paused there, is we could say that this is 1/2 plus 1/2 plus 1/2, right? Which would be, I'm sorry, it's probably 1/2, 2/2 plus 2/2 plus 2/2. And so when I add them together, I would get 2 plus 2 is 4, 4 plus 2 is 6. I'd get 6 over 2, which is 3. Okay, so that's another way of thinking about it. I'm going to erase this because I need more space. This one here, we have 1, 2, 3. And then we have 1, 2, 3, so 3/4. So you have 3 3/4. If we convert this into an improper, this would be 4 times 3 is 12. 12 plus 3 is 15. It's 15 over 4. The last one is going to be 1, 2, 3. And then we have 2/3. So 3 and 2/3. Which could convert to 3 times 3 is 9. Plus 2 is 11. 11 over 3. So there is an introduction to fractions. What you really want to be able to realize is how we did this portion right here. Essentially, if you see a diagram, how do you label 1/4? That's what you're going to be tested on. One thing to note is that on the actual exam, you may, I'm going to fit this in here, on the actual exam, you may see something not necessarily circular, so you might see like a block of whatever, and they'll shade in 1 like this, so we'd have to say that this is 1/3. So don't be freaked out if you don't see exactly a circle. The same process occurs. The other thing that you want to make sure is you read carefully. Sometimes they'll say, what is the unshaded to the total, as opposed to the shaded to the total. So if we were talking about the unshaded, if we said the unshaded would be 2 out of 3. So just make sure you're reading carefully when you're doing this. That's all. Okay, well, let's move on. All right, so the next bit of the video is we're going to discuss how to reduce fractions. And so let's start this off at the bottom. So the first one was 16 out of 36. So how do we reduce fractions? Well, there's a couple of ways of looking at this. The way that most students have learned this is they take the top and the bottom, and they divide both the top and the bottom by something they have in common. So if I see 16 and 36, what are both 16 and 36 divisible by? Now, most of y'all will say, I think will say 2. Some of y'all may say 4, and both are correct. I'm going to use 2 because I think that's what most of y'all would choose. 16 divided by 2 is 8. 36 divided by 2 is 18. And then we would just repeat the process. So then we would just say, okay, cool. So what are both 8 and 18 divisible by? So we'll divide again by 2. This will give me 4 over 9. Okay. Notice, I want you to realize that if I had done 16 over 36, and instead of originally starting with 2, if I divided by 4, I would get 4 over 9 directly. And that should make sense, because if we look at this, what we see is that you have 2 here and 2 here, right? So if you divide by 2 twice, you're really dividing by 4, okay? So when you're doing this, if you can see a bigger number, go ahead and divide through by that bigger number, okay? Now, this is not the only way to do this, okay? So what I do when I see this, let me write this again. And by the way, I'm going to list multiple ways of doing this. You pick the way that works best for you. Okay, so just because I'm doing it, I may be emphasizing one way versus another. If you're more comfortable in one manner versus the other, go ahead and use the manner you're most comfortable with. It doesn't matter as long as you get the answer right. What I like to do is I kind of do the same thing. I kind of cancel out, but what I really do is I just read through, look, see 16, and just think, what times what is 16? So I'll go 4 times 4. And what times what's 36? 4 times 9. And then I'll just turn and be like, okay, well, these 4s match up, and the answer is just 4 out of 9. I find that to be a little clearer, so I break it down. I write the factorization of the numbers, or I just write 2 factors of the numbers. And it's whatever pops in my mind. I may have picked 2 and 8 and 2 and 18, for example, instead of 4 and 4 and 4 and 9. Another way you could do this is, and this is if you're really struggling to see something, what you can do is instead of breaking it down to just simple factors, you could write this as the prime factor. So notice I'm kind of piggybacking off of this. I see that this is 4, this is 4, so I know it's going to break down. 4 is 2 times 2, and then 4 again is 2 times 2. Remember, prime numbers are numbers that are only divisible by themselves in 1. Okay, and we do the same thing on the bottom. So 4 is going to break down to 2 and 2. On the bottom, I'm talking about the denominator. And then 9 breaks down to 3 and 3. So if we do it this way, it is crystal clear what matches up and what we can cancel out. So we know that the 2 and the 2 divide. I shouldn't say really cancel out, I should say divide out, to be clear. And the 2 here and the 2 here divide out. Now, at the end, you have a 2 and you have a 3. They're not going to divide out, and then you have the same thing again. So this is it. This is the answer. So it's 4 out of 9. And the last way, it's probably the clearest way, but you spend a lot of time setting it up this way. But it's a good way of saying, hey, there is nothing else that will cancel out. So as I work through these examples, I am going to use the first way as the way of doing this, simply because I think in my experience teaching this, that's what most students are most comfortable with. But use the method that works for you and compare your answers to mine. So what I'd like you to do, if you haven't done so already, is pause the video and try the rest of these on your own. If you're struggling with it, then stop and see how I did it, do number 2, and then pause the video and finish up the rest, and so on and so forth. So ideally, as you work through these videos, don't just watch the videos. You should be pausing them and trying the problems. And if you're getting it, then you don't even have to listen to everything I'm saying. Just skim through the videos to see which is most effective. See if you're getting the right answer, rather. Okay. All right. So with that being said, let's actually go through and do number 2. So number 2 over here, 20 and 10, and 30 rather, are divisible by 10. Slip of the mouth. And this just breaks down to 2 over 3. And that's reduced. In number 3, we can see that they're both even. What I like is that what we talked about in the first video, the divisibility rules in the first lesson, they are still in effect, right? These both, numerator and denominator, both end in a 0, 2, 4, 6, or 8, and so we can divide by 2. And number 4, we're still using the divisibility rules. They're both divisible by 5, so this breaks down to 1 out of 3. And number 5, they're still both divisible by 5, and this breaks down to 2 over 3. And number 6, they're both divisible by 2. Again, I'm just using my divisibility rules here. So this breaks down to 4 and 11. Sorry, it's a little smashed. Let me change colors. 16, they're both divisible by 2. So this is going to become 8. And 34 divided by 2, if you don't know that, you can always do long division. I know 30 is 15, and then 4 is 2, so that's 17. 12 and 18. Now, you can do with 12 and 18, you could do 2. Actually, what am I saying? You have to do 2. Oh, no, you actually could do 6, right? What am I saying? So we'll do 6. Bigger is better. Gives you 2 over 3. 12 divided by 6 is 2. 18 divided by 6 is 3. But I want you to notice that if you wanted to, you could do you really could do 2. And then you could do 3. And that would work as well. Okay, so I'm going to change the color again. Number 9, these are both divisible by, well, 9. And this is going to break down to 4 over 5. In number 10, 2 obviously would work. 4 would work. And 6 would be the best one to work. So with Oh, no. We can't do 6. I think 4 is the most that I can do here. Let's do 4. So if I do 4, okay. I'll do it with 4. What I was really aiming for was 8. Sorry about that. But we'll do 4. 10 over 12. And then this divides through by 2, and that's 5 over 6. Okay, I'm going to start writing these below 200 over 320. So this is where it starts to get real nasty. One thing you want to do here is that if it ends in a 0, you can just divide those out. It's really what I'm doing is dividing by 10, but you can literally just do what I just did there. And then we'll go through here, and what I'm going to do here is instead of thinking as much as I was thinking earlier, I'm just going to divide by 2. They're both even. And then since they're both even, I'll divide by another 2. And 5 over 8 is about as far as we can go with that. So that's done. Number 12, we have 420 over 560. So you can see the similarity here. We can cancel out those zeros, and we're left with 42 over 56. Not going to overthink it again. I'm just going to divide by 2. They're both even, so we'll do 2. So 21, 56. Well, I know 50 is 25. 6 divided by 2 is 3. 25 and 3 is 28. 21 and 28 are both divisible by 7. And there we have it. Next up, 210 over 350. And I hope what you're doing is you're doing these on your own and then checking your work with mine at the end. Okay, so again, the zeros divide out. 21 and 35. And what actually would be really cool is as you're working through this, if you had picked a different set of numbers to see how your work matches up to mine, that'd be really cool because that'd help you see. The last bit is they're both divisible by 7. And what you're also seeing here is that if you don't know your fractions, if you don't know what numbers are divisible by, if you don't know your multiplication tables, this becomes increasingly difficult. So we're doing 121 over 154. 121 over 154. And this is hard to tell unless you know 11s. So we had mentioned a rule earlier in a previous video that if you do something like 11 times 12, if you take these digits and you put them in the big front and the back, and then you add 1 plus 2, that is what 11 times 12 is. We also had mentioned 11 times 11. Well, we'll just do that. Again, 1 and 1, we put 1 and 1. 1 plus 1 is 2. Okay, and that gives me 121. So I know that the top, I'm going to write this way, is 11 times 11. I actually know that this one's going to be 11 times 14 by reverse engineering this process here. So notice I said we have 1 and we have 2, right? That gives me 12. And I know that this is times 11 because 1 plus 2 is 3. So 1 and 4 gives me 14, and 1 plus 4 is 5. So that's how I know it's 11. 154 is 11 times 14. The 11s divide out, and we're left with 11 over 14. I mean, the other way you could always do this is you could literally just grind this out and divide by, see if it's divisible by 2, by 3, by 4, by 5, and just work your way through. And you really would only have to need to check something like 7, and then you would check 11, because you could use your divisibility rules for the other ones. And if it's most likely not going to work with 4, 6. Well, if it's not even, it's not going to work with 4, 6, or 8. Well, that's not true. Actually, it is true. We know that if it's not, let me put it this way. If it's not even, then you can't divide by an even. The reason why I'm saying that that's the case is that odd times odd is odd, but even times odd is even. So you could test this, right? Like 1 times 1 is 1, and then 2 times 1 is 2, right? So that's always going to be the case. This is not a formal proof as to why it's the case, but this is the case. So if 2 doesn't work, then we know we can't use, and I'm looking here at 121. If it's odd, it's not going to work with any even number. And so remember, every even number can be written as a form of 2. So 4 is 2 times 2, 6 is 2 times 3, etc., etc. So because the top is odd, you don't even need to check 4, 6, 8. So you just really have to check 7, which wouldn't work, and then 11. And then what you realize is 11 and 11, you probably would want to use 11 for the check at the bottom. Okay, so that was a little bit excessive, but there you have it. All right, let's try to finish this up. 90 over 84 is the next one. And I've run out of space, so I'm going to erase this. 90 over 84. Sorry. I'm sure watching me erase is very, very exciting. Okay. So I said 90 over 84. And I'm not going to overthink this. I'm just going to go with 2. They're both even, so I can go with 2. So this is going to give me 80 divided by 2 is 40, so 90 would be 45. What I'm really thinking is that I'm using this sort of logic. If I divide these by 2, I get 40, and this would give me 50. So it makes sense that because 90 is in between, what's between 40 and 50? 45. You don't have to do this, by the way. I'm just trying to get you to think in different ways. If you want to divide just by 2, like so, that's fine. Let me erase this. I'm probably going to need some of this space here. All right, so what did I say? 45. And then 84 divided by 2, that's easy because 8 divided by 2 is 4. 4 divided by 2 is 2. And then 45 and 42 are divisible by 3. And we know that this is 3 because 4 plus 5 is 9, and 9 is divisible by 3. This would be 3 times 15. You know this, by the way, even if you don't realize you know this, because you think of a clock, right? Every 15 minutes, right? So 3 15 minutes puts you at 45 minutes. 42 divided by 3, this one you may have to do. It's going to become 16, and then we're done. By the way, on this one, I actually think the way that I do it is actually going to make your life easier. So what I would have normally do, 45 I'd break down to 5 times 9, and then 42 is 6 times 7. So if you just wrote it as factors, 6 and 9 are both divisible by 3. So this is 3 and this is 2. So I'm left with 5 times 3, which is 15, and then 2 times 7, and I made a mistake. This is actually 14. This is what happens when you don't show your work. So let me be crystal clear here. 3 goes into 4 once. 3, 12, 14. I made a silly mistake. And this is why you can see like there's an advantage to doing it this method, right? Okay. Let me erase this and let's fit the last one here. I'm going to have to hurry. I got about a minute left to show you how to do this. So 84 over 144. Again, you know what I'm going to do? I'm going to be slick here. So I know that 144 is 12 times 12. That's a common factor. So I know I can divide this one by 12. And I'm going to take a shot here. I don't actually know for certain. Well, I do. It's 7. But if I didn't know that, I would still try 12. I think a lot of students know that 12 times 12 is 144. So this would be break down to 7 over 12. And there's your answer. If you didn't know that, you could break it down by 2s and keep working your way through. And if you want to see that, let me know, and I'll make it another video. It's just I have about 15 seconds left. In any case, this is going to be, I'm going to stop here. We've done this page. So hopefully this makes sense. Let me know what you guys think, and I'll see you guys in the next video.